Today's question is: what is the periodic table of elements? Everything around us is made up of matter, and matter is composed of elements. Scientists have identified 118 confirmed elements so far, from hydrogen to oganesson, with oganesson being the heaviest and most recently named. To keep track of all these elements and better understand their properties, scientists use the periodic table of elements, a powerful tool that organizes the elements based on their atomic number and similar characteristics, making it easier to compare and study them. What is the periodic table? The periodic table is a chart used to organize all 118 known elements in a meaningful and systematic way. Each box on the table represents a single element, and the arrangement of these boxes reveals important patterns in how the elements behave and interact. The word periodic refers to something that occurs repeatedly in a regular pattern. This is exactly what a periodic table shows, with recurring trends in the properties of elements across periods and groups. The first widely recognized version of the periodic table was created by Dmitry Mendeleev, a Russian chemist, in 1869. He arranged the elements primarily by atomic mass, but made adjustments to keep elements with similar properties in the same columns, even if the atomic mass order had to be slightly altered. What made his work truly remarkable was that he left gaps for elements that had not yet been discovered, and when those elements were eventually found, they closely matched his predictions in both properties and atomic mass. The modern periodic table is now arranged by atomic number, which is the number of protons in an atom. Although the organization has changed, Mendeleev's contributions laid the foundation for the table we use today and remain one of the most important milestones in the history of chemistry. The periodic table is like a map of elements. Think of it as a special chart that helps us understand and organize all the elements based on their properties. First, we have the periods, or the rows. The horizontal rows are called periods. These go from left to right across the table. Each row is called a period because similar properties repeat at regular intervals as you move across the table. There are 7 periods. The periodic table has 7 horizontal rows, representing different energy levels or shells, where electrons are found in atoms. As you move from left to right across a period, the atomic number increases. Atomic number is the number of protons in an atom. It goes up by 1 for each element as you move across a row. Next, we have groups or families, or the columns. The vertical columns are called groups or families. These go up and down on the periodic table. Elements in the same column are grouped together because they share certain traits. There are 18 groups. The table has 18 vertical columns, each numbered from group 1 to group 18. And elements in the same group have similar properties and often react in similar ways. Because they have the same number of electrons in their outer shell, elements in a group tend to behave similarly in chemical reactions. For example, group 1 elements are all highly reactive metals. Elements on the periodic table are grouped into 3 main types based on their physical and chemical properties. First, we have metals. They are located on the left and center of the periodic table. They are generally good conductors of heat and electricity, and they have characteristic properties such as being shiny or lustrous, malleable or can be hammered into shapes, and ductile, can be drawn into wires. About 75% of the elements on the periodic table are metals, making them the most common type of element. Common examples include iron, gold, and aluminum. Next, we have non-metals. They are found on the right side of the table, except hydrogen, which is on the left but still a non-metal. They are usually poor conductors of heat and electricity. Many non-metals are gases at room temperature, while others are brittle solids. Examples include oxygen, carbon, and nitrogen. And we have metalloids. They lie along the zigzag or staircase line that separates metals and non-metals. These elements have properties of both metals and non-metals, such as moderate electrical conductivity, which makes them useful in electronics and semiconductors. These are materials used to build computer chips and circuits. Examples include silicon and boron.